Welcome to my channel. In this video I will try to repair those remote control. They are from the company Almatic Model Tech 3. They are for sliding gate motor. I will test the battery first. We have 2.9 volt. I will use a newer one, but this one is 2016 and this one is 2032. They haven't the same shape, but I will try to test the remote control. So this one has two buttons missing and this one has a problem maybe with this button. So it transmits. I will test the other button. I will use this probe. It's for SMD testing, SMD compound testing. I will use this probe. I will switch to continuity. It functions. It's better than using two probes to test a component or a button. I will try to test this one. This one it functions. I will zoom in. I will test this one. It functions. This one is damaged. It functions, but it wiggles. I will test this one. It has a problem. 200 ohm. This one is used for remote learning. Now I will try to replace this damaged button. I will remove the button first. Add some fresh solder. I will apply some force from the side. Now I will clean the board. I will add some fresh solder here. Now I will try to solder this button. I will try to use the tweezers. I will solder the other part, other side. We will solder this switch side, then the ground. Now I can add some fresh solder here. We have a very good connection on the other side. I will test now. The function of the remote control. We connect the ground and the positive. Press the button. We have here a flashing LED. So the remote is transmitting. I used this 433 MHz receiver to see if the remote control send some RF power. So we have here the receiver. We have here 4 pin. This one is the plus 5 volt VCC. This one is the ground, and the two in the middle are the output. So I put here a resistor of 270 ohm with a yellow light LED. So this LED will flash if the receiver sees some RF signal. We have an optional antenna here. At this point we can solder an antenna. So the receiver is power on, is powered with this 5 volt rail. I will try to push the button and see the LED. So we can see that the LED flash when it receives RF signal. Now we will try to reverse engineering this tiny remote. In the previous video I said that this chip might be a RF transistor, but in fact it's a whole transmitter integrated in this package. It needs only a crystal of 26 MHz and some passive component to send the RF power to the antenna. The transmit data is generated by this microcontroller and set to this input to transmit the package and to modulate the RF power. We can see that we have here 4 buttons, and we have a clock and data output to this transmitter. The microcontroller used in this remote control is 8-bit from ST Microelectronics, and they use this transmitter, this tiny one, is all-on-one transmitter. It needs only a quarter of 26 MHz. We have here the data and the clock to send the message. We have here some filtering at the output stage. I reverse engineered this tiny remote control, and we have here the schematic. We have here the 4 buttons connected directly to the pins of the microcontroller. And at every push button we have a code transmitter transmitted to the transmitter, RF transmitter, via the clock and the data pin. We have here the quarters connected at the pin number 1. We have the ground, the RF out here, This transmitter contains an inside EEPROM that configured in the factory with the appropriate frequency and power output. So in the factory they program this transmitter at a appropriate frequency. For example, in this one work with the 433.92 megahertz, and they can program also the output power. Back in the day, they use oscillator, and they control the modulation via the microcontroller. For example, this one works with 224 megahertz. But nowadays, they use a VCO and controlled oscillator to generate their F signal. We can see here the internal part of this tiny transmitter. We have here the EEPROM and the VCO, the voltage controlled oscillator, and then we have here the power amplifier. This transmitter worked with on-off key modulation. You can see here that it works with the on-off key modulation. It is the simplest form of ASCII modulation. This means that if we have here the message of 1011, here we have the maximum amplitude, then here we have nothing, and then we have the output power transmitter. And in the receiver, they demodulate the signal. We can see here the output, the clock and the data for when the transmission is enabled. Now we come to the end of this video. Thanks for watching and have a nice day.